Assalamu alaikum, brothers and sisters. Welcome to the journey of quest, where we quench your thirst of knowledge. Have you ever pondered about the importance of geochemical studies in understanding our environment? Geochemistry, at its core, is the science that uses the tools and principles of chemistry to explain the mechanisms behind major geological systems. But it's so much more than just rocks and reactions. It's an interdisciplinary field that beautifully bridges geology, chemistry, biology, and environmental science, providing us with a comprehensive understanding of the world around us. From the air we breathe, filled with invisible aerosols, to the surface waters that quench the thirst of our planet, down to the unseen depths of marine and groundwater systems, geochemistry plays a pivotal role. It's through these studies that we can decode the environmental changes happening right under our noses. We can predict shifts, understand trends, and even prevent potential catastrophes. It's the secret language of the Earth, and we're just beginning to scratch the surface. It's through the lens of geochemistry we decipher the complex codes of our environment. Imagine invisible particles in the air, playing a vital role in our climate. That's exactly what aerosols are. These tiny particles, often smaller than the width of a human hair, are suspended in our atmosphere and are a critical part of our planet's complex geochemical systems. Aerosols are not a single entity, but a diverse group of particles. They can originate from natural sources like volcanic eruptions, sea sprays, and desert winds, or from human activities such as vehicle emissions and industrial processes. Regardless of their origins, aerosols have significant implications for our climate and our health. Let's talk about the climate first. Aerosols can affect the climate in two primary ways: by scattering sunlight back into space and by acting as a nucleus for cloud formation. When aerosols scatter sunlight, they cool the Earth's surface, counteracting to some extent the warming effect of greenhouse gases. On the other hand, the role aerosols play in cloud formation is a bit more complex. They can increase the number and alter the size of cloud droplets, leading to thicker, more reflective clouds that further cool the Earth's surface. However, this cooling effect is not always beneficial. In high concentrations, aerosols can lead to the formation of haze or smog, reducing visibility and contributing to air pollution. This brings us to the second major impact of aerosols, their effect on human health. When inhaled, fine aerosols can penetrate deep into the lungs, leading to respiratory problems and even cardiovascular issues. So, how do these tiny particles form? The process is surprisingly complex and varies depending on the type of aerosol. Some are directly released into the atmosphere, while others form from gas to particle conversion, a process where certain gases react in the atmosphere to form particulate matter. Despite their invisibility, aerosols have a profound influence on our world. They are a testament to the intricate interplay between the Earth's geochemical systems, our climate, and our health. So, these invisible aerosols, with their geochemical properties, are indeed the silent influencers of our climate. Let's dive deeper into the world of aerosols. As we mentioned earlier, aerosols are a diverse group of particles. They come in various forms, from fine dust and sea salt particles to soot from fires and sulfate particles from volcanic eruptions. This diversity is not just in their origin, but also in their size and composition. The size of aerosols can vary greatly, from a few nanometers to several micrometers. This might seem small, but in the world of aerosols, size matters. Larger aerosols can scatter more sunlight, while smaller aerosols can remain suspended in the atmosphere for longer, traveling great distances. Now, let's talk about composition. The composition of an aerosol particle is largely determined by its source. For instance, sea salt aerosols, as the name suggests, are primarily composed of sodium chloride. Dust aerosols, on the other hand, contain a mix of minerals and organic matter, while soot aerosols are mostly carbon. Why does composition matter? Because it influences how an aerosol particle interacts with sunlight and clouds, and therefore its impact on the climate. Now, onto the formation of aerosols. Some aerosols are directly emitted into the atmosphere. These are known as primary aerosols and include particles like dust and sea salt. Other aerosols, known as secondary aerosols, form in the atmosphere from the chemical reactions of gases. An example of this is sulfate aerosols, which form when sulfur dioxide gas, emitted by volcanic eruptions or burning fossil fuels, reacts with oxygen. Understanding the diverse world of aerosols, their formation, size, and composition is crucial in our quest to unravel their role in our climate and health. In the dance of light and particles, a fascinating story unfolds. Aerosols, as we've learned, come in various sizes and compositions. But how do they interact with the sun's rays? When sunlight hits an aerosol particle, it doesn't simply pass through. Instead, it gets scattered in different directions. This scattering effect can be quite dramatic, especially with larger aerosols. It's akin to a mirror reflecting sunlight back into space. But that's not all. Aerosols can also absorb sunlight, transforming it into heat. The balance between scattering and absorption depends largely on the aerosol's composition. For instance, soot aerosols, being dark and carbon-rich, are excellent at absorbing sunlight. On the other hand, lighter aerosols like sulfates scatter more sunlight. This scattering and absorption of sunlight by aerosols has a cooling effect on our planet. How, you wonder? As aerosols reflect sunlight back into space, less of it reaches the Earth's surface. This means less heat, leading to a cooling effect, often referred to as the aerosol radiative forcing. This effect can partially offset the warming caused by greenhouse gases. However, it's important to note that this cooling effect varies greatly depending on the location and type of aerosols. It's also not a long-term solution to global warming. Aerosols have a relatively short atmospheric lifetime, usually just a few days to weeks, compared to greenhouse gases that can persist for hundreds of years. In the grand scheme of things, understanding the relationship between aerosols and sunlight is vital. It helps us unravel the intricacies of our climate system and the role aerosols play in it. As we continue to explore this fascinating world, we are reminded of the delicate balance that sustains life on our planet. From the cooling tales of aerosols, we now shift our gaze upwards to the vast canvas of the sky. Here, clouds, those floating ephemeral wonders, play a leading role. But did you know that aerosols are the unsung heroes behind every cloud? That's right. Aerosols influence cloud formation, acting as the seeds around which clouds grow. These seeds are known as cloud condensation nuclei. Without these nuclei, water vapor in the atmosphere would find it difficult to condense into droplets, making cloud formation a challenge. Aerosols provide the necessary surface for water vapor to latch onto, facilitating the birth of a cloud. The more aerosols in the atmosphere, the more cloud condensation nuclei, and consequently, the more clouds. But it's not just about quantity. The size and composition of aerosols also matter. Larger and more hygroscopic aerosols, those that are good at absorbing water, are more likely to become cloud condensation nuclei. This interaction between aerosols and clouds doesn't just paint pretty pictures in the sky, it has far-reaching implications for our weather and climate. More clouds mean more sunlight reflected back into space, further enhancing the cooling effect we discussed earlier. But there's another twist. More aerosols can lead to clouds with more, but smaller droplets. These clouds tend to be brighter and last longer than their counterparts, again reflecting more sunlight. But what about rainfall? Well, clouds with smaller droplets are less likely to lead to rain. This is because smaller droplets take longer to coalesce into raindrops. So, paradoxically, more aerosols could mean less rain, altering precipitation patterns around the world. As we delve deeper into the atmospheric dance of aerosols and clouds, we begin to appreciate the complexity of our climate system. Every cloud does indeed have a silver lining, and often it's laced with aerosols. As we leave the realm of clouds and aerosols, we venture into a less picturesque aspect of these microscopic particles. Yes, they play a crucial role in climate and weather, but aerosols have a dark side too, especially when it comes to human health. When we breathe in air, we're not just inhaling oxygen. We're also taking in a cocktail of aerosols, some of which can be harmful. Depending on their size and composition, these particles can travel deep into our respiratory system when we inhale. The smallest, known as fine particles, can penetrate the deepest, reaching our lungs. Here, they can cause inflammation and damage, leading to respiratory problems. Some of these particles are even small enough to cross into our bloodstream, where they can trigger a cascade of harmful effects, affecting not just our lungs, but our heart and other organs as well. It's no surprise then that aerosols have been linked to a range of respiratory diseases, from asthma to chronic obstructive pulmonary disease and even lung cancer. And it's not just the direct effects we need to worry about. Aerosols can carry toxic substances like heavy metals and organic pollutants, delivering these dangerous hitchhikers straight into our bodies. We've seen how aerosols can shape clouds and influence climate, but as we delve into their dark side, we realize that they can shape our health too, in ways that are far from beneficial. As we continue our journey into the depths of geochemistry, let's not lose sight of this double-edged sword, the intricate dance between the natural world and our own health. As we step away from the dark side of aerosols, we take a moment to reflect on their role as silent influencers. These minute particles, often invisible to the naked eye, hold sway over our climate and our health. But why are aerosols so important to study? Aerosols are a significant player in the climate system. They can scatter sunlight back into space, cooling the Earth's surface, or they can absorb sunlight, warming the atmosphere. Aerosols also serve as the seeds on which cloud droplets form, influencing the quantity and type of clouds in the atmosphere. In turn, this affects rainfall patterns and the Earth's energy budget. Beyond the climate, aerosols also impact our health. We've seen how they can carry toxic substances and penetrate deep into our respiratory system. By studying aerosols, we can better understand these effects and work towards mitigating them. So these invisible aerosols, with their geochemical properties, are indeed the silent influencers of our climate, our weather, and our health. As we continue our exploration of geochemistry, we should keep in mind the critical role these tiny particles play in our world. Water, the essence of life, holds many secrets in its depths. Imagine standing by a serene lake or a rushing river, or even on the edge of the vast ocean. What you see is just the surface. Beneath lies an intricate world, a complex labyrinth of geochemical processes that shape the health of our planet. Geochemical studies of surface, marine, and groundwaters are like a deep dive into this underwater universe. They are our way of decoding the secrets that water holds, of understanding the invisible threads that connect all life on Earth. These studies allow us to investigate the presence of pollutants in water bodies, whether they are toxic metals in a river, harmful microplastics in the ocean, or even pesticides seeping into groundwater. By tracing the journey of these pollutants, we can uncover the sources of water pollution and devise strategies to combat it. The waters of our world are not just passive recipients of pollutants though. They are dynamic, reacting and adapting to these intrusions. One such reaction is ocean acidification, a process where the ocean absorbs carbon dioxide from the atmosphere, leading to a decrease in pH. This can have far-reaching effects on marine life, particularly on creatures that build shells and skeletons, like corals and mollusks. Groundwater, too, is a part of this intricate web. Contaminants can seep into the ground, polluting the water that lies beneath our feet. This can impact not just the health of the ecosystems that rely on this water, but also our own health, as groundwater is often a source of drinking water. Geochemical cycles, the processes that move elements and compounds through water, air, and soil, play a crucial role in these interactions. They help maintain the delicate balance of life in water bodies, shaping the health and diversity of aquatic ecosystems. As we dive deeper into the world of geochemistry, we realize that every drop of water tells a story. Do you know how geochemistry serves as an environmental watchdog? A curious question, indeed. Yet the answer lies in the very soil we tread, the air we breathe, and the waters that encircle our planet. Geochemistry, the science that merges geology with chemistry, is not merely a theoretical discipline confined within the walls of a laboratory. It's a practical tool, a silent sentinel that monitors the health of our environment. Geochemical studies, through the analysis of elements and isotopes in nature, help us track pollution sources, understand soil degradation, and even predict natural disasters. Picture this: a river tainted with industrial effluents or a landscape scarred by acid rain. How do we discern the source of such pollution? Geochemical fingerprinting, that's how. By analyzing the unique chemical signatures of pollutants, geochemists can trace them back to their origins, aiding in the enforcement of environmental regulations and the mitigation of further damage. Now let's delve beneath our feet. The health of our soils is of paramount importance, not just for agriculture, but for the entire ecosystem. Geochemistry plays a crucial role here too. It helps us understand soil degradation, the silent crisis that threatens our food security. By studying the chemical composition of soils, geochemists can identify nutrient deficiencies, contamination, and other issues that may compromise their health. But the role of geochemistry extends even further. It aids in predicting natural disasters. Volcanic eruptions, earthquakes, even landslides leave behind geochemical footprints that scientists can read to gain valuable insights into the patterns of these catastrophic events. This knowledge empowers us to better prepare for and potentially mitigate the devastation they may cause. Beyond monitoring and prediction, geochemistry also provides solutions. It helps in developing methods for carbon sequestration, a key strategy in our fight against climate change. It aids in the exploration for renewable energy sources like geothermal energy. The applications are vast and the potential is enormous. Geochemistry, thus, stands as our silent guardian, keeping a watchful eye on our environment. It's an unsung hero in the quest for a sustainable future, a champion in our fight to preserve and protect our precious planet. What does the future hold for geochemistry? As we stand on the precipice of an era marked by rapid technological advancements, we can't help but be optimistic about the future of geochemical studies. The field of geochemistry is poised to reap the benefits of these advancements, especially in areas like data processing and analysis. The exponential increase in computational power is set to revolutionize the way we analyze geochemical data. Imagine being able to process and interpret data from millions of aerosol particles in a matter of seconds. This would not only expedite our understanding of the environment, but also provide us with real-time insights into the state of our planet. And it's not just in the realm of aerosols. The future of geochemistry is also bright in the study of surface, marine, and groundwaters. Advancements in remote sensing technology and the development of more sophisticated underwater drones promise to grant us unprecedented access to the deepest and most remote parts of our oceans. This could lead to a deeper understanding of the geochemical processes that govern these marine environments and how they contribute to the overall health of our planet. But perhaps the most exciting prospect of all is how geochemistry could contribute to sustainable development and environmental conservation. By providing us with a detailed understanding of our environment and the processes that govern it, geochemistry could help us devise more effective strategies for combating climate change and preserving our natural resources. It could, for instance, help us identify and harness new sustainable sources of energy or develop more efficient methods of water purification. The possibilities are virtually limitless. As we continue to push the boundaries of what's possible in geochemistry, we can look forward to a future where our understanding of the environment is deeper, our actions are more informed, and our impact on the world is more positive. As we gaze into the future, geochemistry promises to be a beacon of hope, guiding our path towards a sustainable environment. Thanks for watching us share our videos. Subscribe our YouTube channel and press the bell icon and stay curious for new uploads.